record on this computer. So already we missed some important discussion. That is, we are mining. We are showing you how mining works. So this is called mining in the blockchain. This is called proof of work. Whenever a new block is produced, for example, here a new block, and the content of this new block is Ashraf, and nonce was at the beginning 0, nonce is 0. So this time the hash of this block is, this is the hash. This is the beginning hash. This is the hash of the original data. This is the hash of the data that was when the block was created for the first time. This is, so now what every node will do, assume that there are 100 nodes in the blockchain. Every node will mine and they will produce a target hash. Here our target hash, the difficulty level of our target hash here is 40. So we can see that a node, we don't know which node actually generated this target hash first. We don't know. Just assume that one of the node did that, and the node has to increment the nodes 2593 times. Every time it has incremented the nonce one by one. So this way it has to increment the nonce 2590 times. Next, another example. The things will be clear to you well from the next example. Assume that this is the block 1 and the nonce, the initial nonce, we know that this is 0, and I will put some data. For example, MIT. This is the data of my transaction. Or maybe I am sending you $1,000. So 1,000 is the content. And we can see that the previous, we know that every block contains the hash of the previous block. So as this is the block number 1, and if we say that this is our first block, that's why we don't have any previous block. That's why here the field of the previous block is 0. All of the value is 0. What's the reason? This is the genesis block. We are assuming this is the genesis block, and we don't have any block that was already committed in the block. Since so this is the first block, and this is our data, and the hash of the content of the current block is this is the hash. So if you produce hash again from the content of this block, you will again get this code. If you don't change the nonce field, or if you don't change the data, then you will get the same data. This is the properties of hash. But what we are here, what we would like to do here, that we would like to generate the target hash. So that's why we'll click the mine, and every node will try to generate the target hash. So it is mining. We can see that one of the node has to increment the nonce field 47,510 times. Then it came up, and you also notice that this time it took some time to produce this target value, this target hash. It will not change the block number, it will not change the data and any other things. Only this nonce will be changed, and repeatedly it will try to produce the target hash. For example, this is the second block. Already this is committed in the blockchain. This is the second block, and the nonce of the second block also 0 at the beginning, and the data is, suppose this is another transaction, for example, is coming from you. So 200. And notice, before producing the target hash, every node will put the hash of the previous block in the field of the previous in this block. Here, see, this block is containing the target hash of the previous block 40 at the beginning of this hash 408989. So the next block number 2, that is going to be committed in the blockchain, containing the hash code of its immediately previous block. The target hash of its previously committed block one. So it is containing. So primarily it is containing some data. One is block number, another is nonce, and um, another is data and previous block. Now every other blockchain node, like the previous one, will also mine. Will also try to produce the target hash for this block. Target hash, that means the difficulty level will be 4. That means at the beginning of the hash code, there will be 4. Just give me a few minutes. I like to send this link, the meeting link, to someone else if anyone is interested. From where will generate meeting link. Okay, participant invite, copy invitation. Just few minutes. I'm taking you from it for few minutes. So we are here again. I just invited a student. She is interested to know about this topic, so that's why. So we were here. Let me describe it again. I'm trying to make you the things clear. That's why I'm just describing again and again. So the block 2 already we have. So we'll mine this. Let's mine this. Click the mine. So assume that actually it is being done by every node in the blockchain. Here I am doing, but you'll imagine that so this is being done by every other node. It's being done. So we can see that this time for committing this block, the blockchain, one of the blockchain node has to increment the nonce 13,000 okay, many times. So these and also I think that I should make you clear that I'm saying you that a node has to increment this time. Actually, the node has to produce um, hash code this time, this number of time. So this node has to run the hash function this number of times. This number of times. Not only increment. First it increment the nonce, then it needs to put this block into the hash function, and the hash code is being produced, and need to check that or whether the hash code has the 40 at the beginning. So many things it needs to do. It requires sometimes. That's why every node will not be the winner. One of the node will be the winner here. Although every node win it, but one of the node will win. So we have mined it. If you again click it, then same things, you will find the same result. So already we have two block that has been committed in the block set. This is block 1, this is block 2, and now let's see another block. For example, this is block 3, and at the initial stage, this block will have also nonce field 0 and data. For example, this block has 3,000 is the data, and you notice that this block is containing the target hash of the previous block of its previous block. This is the previous block 00. So this is we are called that they are creating the link among them. So this is the linked list. This is the chain of block. So this will ensure us that no one has sensed our block. I will show you that how we can't sense the block because of this link. As we are putting the previous hash previous block's target into the current block, so that's how you can't sense. This will prevent us from sensing any block. So let's see, we are going to mine this block also. And we are seeing that it is taking some time, and already this block is mined. And we can see the target hash of this block. This is the target hash of this block, and this block also containing the target hash of the previous block. This is now, for example, think that I am a malicious attacker and I like to sense the data. I will write here that I send you 4,000. Now you can see that the block is starting from this modified block. All of the blocks now red. Look red. Why? Because already sensed. How it can be understood sense? Because if I sense the 400 here, then this hash has been sensed. The hash sense, and as we know that the target hash of this block is stored in the next block. So previously it got the target hash different one. Now it is getting another new one. So that's it. But the first one has not been affected. The reason is first one is not containing the hash of the second one. Second one is not containing the third one. If you would sense the third one, it would not actually sense the previous two one. Let's see. For example, we are mining again. So if you would like to sense the node, every other node needs to mine this block, but every other node will not mine for you, and you can't even alone mine the block for uh, every computer, because every computer stores these things. So it's not possible. Although we are here saying that it is possible, but in reality, it's not possible. Here I am sensing just one computer. Okay, I will be sensing block. I will be producing new target hash after sensing a block for my own computer, but other node will not agree with me, because they will say that okay, we have already committed block 2. Why you are telling me to commit again 2? You are a fraud. Uh, you are a attacker. So they will ignore me. So let's sense the data of the block 3. Now you can sense this is only the red. Other previous two are not the red. So this is the proof of work, and using this proof of work, a block is omitted. A block is included with the already existing chain of block. Hopefully, those who attended the Amar class, and now after seeing this example, now you are clear about the block sense activity. I hope that. Even I can show you another example how you can develop your own blocks. And another example I will show you. Let's see that example. After seeing that example, then I will show you how you can use the blockchain for developing an application. Why it's not working? Okay. Uh, okay, I will show you another example of blockchain. Let's see another example of how blockchain works. So I have a code on the desktop. CD. Let's go to desktop, and the folder name is own blockchain. So now I'm going to show you how our sample blockchain works. I already covered a lot of theoretical aspect, but we did not see how blockchain works, how transaction is being added in the blockchain, and also how transaction look like, and how we can develop our own blockchain, a sample blockchain. We did not see those things. Now we'll be seeing that things. So let's run the program. Within this folder, I have a program. That's the Python code. So I need to run that program, Python, and then the program name, and the node name. So here node name, that means node number, port number. I like to make another things clear here that we are running a blockchain in a single computer. In real life, blockchain does not run on a single computer. Blockchain runs on multiple computers. So as we are running on a single computer, so we are assuming here that we'll have a one or more node, 2 or 3 or 4 node, 2 or 3 or 4 computer here. We are simulating. We are simulating computer, and for every node, we are giving the port number. In other words, you can assume that this port number is the IP address. Is the IP address of every node. So here first I am just taking only single node, a node, and this node name is 5000. Actually, this is the port number. So my node will run with this port using this port 5000. So our code is blockchain.py. This is the blockchain. I'm going to create a blockchain node, and this blockchain will have the IP address 5000. Just think that, although this is the port number. So we'll have only a single node. So let's wait to run this block. To run this node. So we are running a single node, blockchain node. What I will do, I'll just copy this URL. It should open from a tab. Just let me copy it. Why we can't copy that one? Okay, let's okay. Now it is what? Not found. Okay, in another way, we'll show you that one. Let's see. Perhaps I'm just doing wrong. We need to just install a Postman. Postman for Chrome. So by using this app, so we can interact with our blockchain node. So this if you would like to interact using the API application program interface, I think computer science student will understand this, but I will not discuss it in detail. Just know the name API. Um, so this is Postman. This Postman is an application. If you would like to interact with any server or any node, then we can use this Postman. So here we already run our server or run a single node. I'm showing you a single node on the here. We can see that it is already running. So now we would like to interact with this one. So this is a blockchain node. Before that, I like to show you the code. If you don't see the code, actually what we are running, then that does not look good. Just I am showing you code that we are running here. Blockchain code. I'm trying to make the things faster, but okay, everything will take time. In the meantime, maybe we can see. So first, let's see how our blockchain looks like. So here we are actually just issuing a API call. So this API call, this is localhost 5000. That means the address of the node that we are already running, and the localhost, that means where actually this node is running in our PC. This node is running, and we just called a API blockchain. This blockchain will show us the already existing chain. So in that case, as this node just run, we can see here only one block it is showing that, and this is called the Genesis block, and hash of the previous block. Here, see there should not be hash of any previous block. In this is the Genesis block, and this is the index 0. That means Genesis block, and nonce just a random, and the timestamp when this block was created, and also the transaction. This block will not have any transaction. We know that, as this is the basic block. Now, if we would like to create in a new block, then what we will do? First, we need to generate the transaction. So first, let's make some transaction, and then we'll mine. And next, we'll see how many blocks in the blockchain. And again, I would like to remind you that we are running only a single blockchain node. You might have two or more node. You can add two or more node. So this is the blockchain code. This is blockchain Python code. You can modify this code. You can add a new feature with this code. I think you can benefit from this code. Just a sample code. So let's see how we can add the transaction in this block. How we can produce transaction. So to produce transaction, we need to issue or a command, API command. If you would like to new transaction, add a new transaction in the blockchain, then this is for that purpose, transaction new. You'll call a function, or you'll call a API. This is transaction and new. That means we are going to create a new transaction. So how the transaction will look like? We know that a transaction has a particular structure. I mean, sender address, receiver address, and the amount. A basic, just a basic some information of a transaction. A transaction might have other information or two. So here, see, I'm going to just put a transaction, and my transaction looks like that. Senders. This is the receiver address, and blockchain always maintain the pseudonymous address. Never will use the real address. Every transaction will happen in the blockchain anonymously. No one will understand who you are. So this is the recipient. This is sender. This is the recipient, and the amount that you would like to send this recipient that you mentioned. So let's click the send, and we can see that one transaction will be added to block 1. Why block 1? Because the Genesis 1 block 0, the new block that is going to be created, that's block 1. And again, I would like to create another transaction. For example, you, this one was mine, and now you are giving another transaction. So you like to send someone $110 and just sends the recipient address a bit. Also here just sends recipient address and then send this transaction to the blockchain node. Okay, another transaction will be added to block one. This one also will be included in block one. At the moment, we know that block one is going to be created. So that's why all of the transactions that I will be creating will be included in the block one. If I set any limit of the transaction in a block, then that's the different things. As in this code, we did not actually set any limit of the transaction that can be included in a block. So that's why as many as you like, you can include. Until you mine this block, you can include a number of blocks. In real block set, this will not happen. In real block set, they will produce block after a certain time. So within that certain time, the block that will the transaction that will be produced will be included in that block. But here, as we are just creating a sample one, so that's why this is like that. So now let's mine a block. We are just creating transaction, and transaction are being stored in the transaction pool, but no block has been still created. So let's mine a block. In order to mine a block, you need to give a command. You need to call a FEI. This is the mine. So if you issue this command, then a block will be created with the transaction that already are created by us. So mine. Okay, a new block is mined, and see this block has 3 transactions in this data part. And you can raise a question that where is the marketability? We know that transactions are packed in a marketability, but here they did not make it a marketability. So this is the lackings of this block set. I have just included this marketability features in another version, but I am showing you here the basic version. So ignore this part. And also the index of this block, we can see that one, and hash of the previous block. So this hash is the hash of the Genesis block that we actually saw in the beginning. So and this nonce indicate that to produce the target hash from this block, you need to sense the nonce this times. You need to sense this time. We can't see the hash target hash here. They did not include the target hash here, but it's okay. You can include in real blockchain target. You'll see the target hash. So now we are interested to see the complete chain of block. Already our blockchain should have 2 blocks. Previously we saw only 1 block, but now we should see the 2 blocks. So let's issue this command again. Let's issue this FEI again. Send. Okay, now you can see that chain of block. This is the Genesis block, index 0, and no transaction. And the next block is index 1, and also you can see the next block has the 3 transaction. Sorry, 2 transaction. 3 block should have 2 transaction, but here you can see an extra transaction. The reason is this transaction belongs to the minor. This transaction belongs to the winner, because a node, one of the node mine this block, one of the node could produce the target hash. So that node should receive some incentive. So this incentive will be also included in the blockchain as a transaction, and this transaction will have some value, and this is the this is 1. Here we are giving him just $1, for example, or 1 crypto One Bitcoin has huge value. And the sender here, zero, uh, because no one is sending. The system is giving this miner some money. So that's why sender is zero. But there will have recipient because one of the node will be the winner. So there should have a one recipient, but there will be no sender because the system will give this money. So, okay, I think now you have some good idea also. And here we just displayed this example by giving only a single node. But if you would like to uh, see how blockchain works by adding after adding another node, I can also show you that one. But I like to just ignore that part. Let's come back to our lecture. So now I am going to show you some useful things for digital forensics. But before that, I need to discuss some basic about decentralized application. So let's describe some application layer. Already we mentioned that blockchain has an application layer on top of every other layers. If you would like to develop an application, then even you don't need to the basic of blockchain or underlying structure. You don't need to know that. What you need to know that you need to know the application layers related protocol and application and programming. So in order to develop any application, uh, we need a user interface. So first of all, we need to make our environment ready. That means we need to install some software. The first tools that you need to install is node.js. If you would like to develop any decentralized application, then you need to install node.js. Let me give an example of a decentralized application. You already have heard about um, digital voting system, digital voting, election voting. Or another example, I will just tell you another example is the COVID vaccine information. Nowadays, what we do after using PCR device, it's called PCR, yes, PCR testing device. Then we get a certificate, COVID-19 certificate, like whether someone is infected with COVID or not, negative or positive. And government would like to know about this information for the purpose of contact tracing, so that government can contain the COVID-19. COVID-19, they can stop COVID-19 from further spreading. That's what they need it. But as a user, we don't want to give the government to know about myself, about me. The reason is I'm feeling that, okay, I can't actually preserve my confidentiality. Any other people may know about me that, okay, he or she is infected with COVID. No one wants anyone know about him. But in the current system, we can't hide our name. We need to give the government information. In actual cases, in order to serve our purpose, we just need to know that in a certain area, how many person are being infected with COVID, but we don't need to know about a person. We don't need to know the detail about a person, we don't need personal information. So how we can avoid that things? If you use the blockchain, then you can avoid that things. The blockchain can preserve the confidentiality and privacy for you. What you will do, when you will test your document, when you will get your document COVID-19 certificate, Then you put that document in the blockchain, and the blockchain will not take your real information. What blockchain will? Blockchain just keep this information using your public key. You can add your location and other necessary information except name and other information that will help you to identify. Just avoid that giving that information, but you can add the location and also the result positive or negative in the blockchain. Government can track the blockchain, can monitor the blockchain to know about the density of the COVID-19 infection. Blockchain, no one will know about you. So how can you develop this kind of application in blockchain? I am just now describing that things. To develop such kind of application, you need to follow for some procedures. You need to learn some coding, and you need to be familiar with some tools and technique. Today, I will not actually describe the tools or technique. And similarly, we are saying that, okay, we are up to using this blockchain in digital forensic. But how we will use this blockchain digital forensic? Already, I think you know how you can use the blockchain in digital forensic. The biggest challenge in digital forensic is to ensure the integrity of your collected evidence. If you put the evidence in the blockchain, then blockchain will ensure you that your data, your evidence has not been changed. Even you can say that, okay, in normal system, I can also do that. But in normal system, your data will be maintained, will be stored by a single entity. Single entity has all of the authority to change your document. If it sends your document and produce a new hash, how you will tell that, okay, it has not been changed? But in case of blockchain, how many data from how many computer you will sense? Not possible. From how many computer you will sense the data in blockchain? Maybe you can convince one or two computer, but you can't sense the data from all of the computer. So in digital forensic technique, if we produce the hash from the digital evidence and put the hash in the blockchain, then anyone can verify whether the evidence has been sensed or not. And another use is to ensure the provenance. Like you are producing this evidence, later you can claim that no, you did not do that. But in blockchain technique, you can't say that, okay, I did not put it. Who are the source? That can be easily understood from the blockchain. And also chain of custody. That means today I am investing some cases. Next day, I am investigating the same case, but at another stage. Maybe I am just looking for further information or maybe more information. Then next day, I will have another set of evidence. After 3 or 5 days, then I will have another set of instruction. So if I put evidence collected um, every day, collected from collected today or maybe tomorrow and the day after tomorrow, and put them in the blockchain will actually display us those evidence in the form of chain of custody. It will show us the time when we have inserted the document, and also it will ensure the integrity of all the evidence that have been stored in the blockchain. So this way, we can use the blockchain for preserving digital evidence in digital forensics. For other purpose, you can also use, not only for this case. um, if you would like to collect evidence from multiple sources, then the blockchain is the best option. Every digital forensic expert will be connected to blockchain, and from different corner of the world, they will put the digital evidence in the blockchain. And the proper authority, the concerned authority can monitor and track all of this digital evidence at the same time. So I have just mentioned a use case of the blockchain for preserving digital evidence. So here, let's say that I told you that in order to develop such kind of decentralized application, you need to follow some procedure. First of all, you need to make your environment ready. And in order to make your environment ready, first of all, you need to install the node.js. If you click this link, then you will have this node.js, and also you will have some instruction how you can install this node.js on your computers. Next thing is, if you would like to put something on a blockchain from our user interface, then we need a blockchain. So what are the options to have this blockchain? First option is you will develop your own blockchain. That will be a time consuming, and a single person can't actually develop a blockchain, because a blockchain actually involves a lot of different technology, different difficult technologies. A company can actually develop a full featured blockchain, but a single person, it will be hard for a single person to develop full featured blockchain. So this is one way to develop your own blockchain. Another one is, already there are many enterprise blockchain, already established enterprise blockchain. One of the popular blockchain is Ethereum blockchain. You can just install a local Ethereum blockchain on your own computer. So that will be separated, totally separated from the public official Ethereum. If you change your blockchain, then nothing will happen with the official Ethereum blockchain. But the thing is, if you would like to the public blockchain, official public blockchain, Ethereum blockchain, to run your any testing application, or to upload your any document on the Ethereum blockchain, then you need to spend money. No one will give you anything without cost. I mean, free. So you'll have to spend some money to use the public Ethereum blockchain. So that's why we always prefer a local Ethereum blockchain. We normally install a local Ethereum blockchain, and that's called the Ganache. The next software that you'll need is Starful framework. The Starful framework will help us to compile our smart contract. Smart contract that I already mentioned, that this is a set of programs are normally deployed on the blockchain. Blockchain node can run this program the similar way as we run a program on our computer. Similarly, the blockchain node also can run your program. So your program is called the smart contract. But before deploying your program on the blockchain, you need to compile your program to see if it is working or not. So that's why you need a Tarful framework. This will help you to run and debug your smart contract. And another tools that we need, that's called MetaMask. This is one kind of web browser. If we would like to interact with blockchain, then we need a special web browser. We can't use our Chrome web browser and also the Microsoft Explorer browser to interact with the blockchain. This browser does not support blockchain, and blockchain will not allow this browser to communicate with blockchain. So that's why developer or researcher develop the MetaMask. There is actually an extension on the web browser. Like in the existing web browser, you will add this extension, MetaMask extension, and this extension will communicate with the blockchain, with your local blockchain or your global blockchain. So these are the tools that will be needed to develop a blockchain. Next, you need to know some programming language to develop of your front-end application. A decentralized application normally has, we'll say that three part. One is the user application, another one is the blockchain, and on top of the blockchain, you will have the smart contract. So to develop a smart contract, to first of all, you need to develop a user interface. I will show you that how user interface works after a few minutes. So first you need a user interface. To develop the user interface, you need HTML, CSS, JS, JavaScript, React. And for developing a smart contract, the smart contract that actually will be called from your user interface. This smart contract will be developed using a Solidity language. And for developing and as an editor, you can use the Visual Studio or Remix. This is online tools. After writing your user interface and also writing your smart contract, the next task is you need to test your smart contract, whether your smart contract is running okay or not. The reason is if I upload this smart contract on the blockchain, then blockchain will incur money, will incur cost, will take money from us. So if something is wrong with our smart contract, then we'll be spending money with unnecessarily. That's how that will be lost. So that's why we need to test the smart contract before uploading the smart contract on the blockchain. When everything will be okay, then we'll deploy the blockchain and our user application will interact with the blockchain. Now let me show you an example of such kind of application, and that application will be discussed in the context of digital forensic. So we'll discuss that application in the context of digital forensic. Let me show you. Okay. So this is the content of our today's lab. Now we came to the content of today's lab. I think I should show you is just diagram of a decentralized application. This one I'm showing. So the application that we are going to see look like this figure. So we'll have a user interface. This interface might be developed on our computer or maybe mobile. So this is application. And there will be a blockchain. This is Ethereum. We'll be using Ethereum blockchain. And this Ethereum blockchain will have a smart contract. This is program. This program will run on the Ethereum blockchain. And there will be another blockchain-like storage system. This is called decentralized storage system. It is called IPFS, Interplanetary File System. Why we are actually taking this decentralized file storage? Already blockchain will give us some storage, but the thing is the heavy file cannot be stored in the blockchain. You can store a single hash code in the blockchain. You can't store the whole evidence. The evidence will have big size. That evidence in the blockchain. Why you can't? The reason is it will cost money. It will cost huge amount for you. Ethereum will not allow you to put anything in the Ethereum without cost. So that's what we will do. We normally use different free decentralized file storage system. We'll send our digital evidence in this file system IPFS, but the hash code of that evidence will be put into the blockchain using this smart contract. Smart contract will help us. So first of all, from a user interface, we will take the digital evidence. Then that evidence will be sent to a storage system. This storage also um, is made following the blockchain technology, but this is lightweight. This is this can actually store huge amount of data, and this does not cost you money. So that's why you'll send it. It's called IPFS. And this IPFS properties is that they will send you a hash of your document that you already stored in this IPFS. It will send you the hash code of your document. And next, your application will call a smart contract and will give the hash code. And that hash code will be stored in the Ethereum blockchain. So later, if anyone would like to verify the hash code, or you would like to verify the integrity, that what he will do, he will take the content of the evidence from this IPFS and will produce the hash code, and will also take the hash code from the Ethereum blockchain, and he or she will try to match um, the hash code from Ethereum and the hash code from IPFS. If those two hash code match, everything is okay. Otherwise, everything is not okay. So this is the application. This is we are going to discuss. This is we are going to show you that how it is working, how it will work. So here in this lab, you can get the content of this link of this lab from by going through this link. We have discussed how blockchain can help in digital forensic. I don't like to repeat these things again. We can ensure the integrity, authenticity, auditability. If we put that digital evidence in blockchain, then we can ensure these things. There are many implications of this powerful tool in digital forensic. They also discuss that it will reduce the cost, and it will reduce the fraud things, and it will ensure the transparency. 100% this transparency will be maintained here. It's granted if you use the blockchain. And this is one of the use case as a for maintaining the chain of custody. You can use the blockchain. You can keep the record. Even if you can bear the expense, then you can um, store your whole digital evidence in the blockchain, or maybe you can design a cost-effective blockchain, and then you can put all of your digital evidence in that cost-effective blockchain. Another use case example here, it is showing that to keep the record of hotel visitors, hotel guests. We know that every hotel managers need to provide the government with guest list. When a guest is coming to a hotel, when guest is leaving the hotel, and how many days a client or customer stay in a hotel. All of these things should be actually sent to the government agency or government people. Every manager needs to send this document to government office every day, also every day, because they need to uh, observe or monitor what is happening in a hotel. If anything, if any unfavorable incident happened in a hotel, then there might come investigation. So law enforcement will need guest information. If you use the blockchain for keeping this registry information, for keeping this guest related information, then user or customer or guest privacy confidentiality will be maintained, and also the government office, they will be able to track and monitor the document. No one's privacy will be hampered here. No one will be violated here. And as a digital forensic expert, you will be able to retrieve valuable information, valuable evidence from such kind of hotel related things. So this is another, that hotel registration, tracking and missing. If any person is missing from the hotel, then you can track the criminal evidence from the blockchain. So this is the another use case of the blockchain. Now let's come to the point how we can develop such an application using the blockchain to keep our digital evidence. So first of all, you will take a digital forensic report as an input. You will take a digital evidence. Very often we generated the report from Pro Discovery or maybe OS Forensic. So imagine that you have one kind of digital evidence. Next, the evidence will be converted into the buffer. This is buffer. This is another file type. This will be converted into code level. You don't need to worry about it. So after that, that converted file will be uploaded to the IPFS. I already told you that IPFS is also P2P network that is also designed following the blockchain technology, but it's lighter than the blockchain and it does not cost the money. We are using a free service. There are also some decentralized storage that will cost money, but this IPFS technology will not. And next, this IPFS will send you the hash of the digital evidence that you stored there. And next, you need to use the MetaMask to interact with the Ethereum address, Ethereum blockchain. So now by using the MetaMask, you will put this hash into the blockchain, Ethereum blockchain. So this is all. And for developing this application, you need some tools and technique, tools and programming language that's here are listed. Solidity is needed for making the smart contract. IPFS already said React for user interface. So let's see how we'll do that. First of all, we need to install the node.js. If you go to the internet, if you click it, then you'll have the node.js. Already, I install node.js, and you can check whether my computer has node.js. If we write node, then we can see that it is showing us welcome to node.js and it is showing a version. So if you don't have this node.js, then you just click this node.js. Here I have provided you with a link. By clicking this link, you can have the software for installing node.js, or you will have the command to install this. You can use the Mac, or you can use Linux computer. Mac and Linux are preferable, but Windows is also okay. You can use your Windows too. Next, we need to install some dependencies, some other tools, as we will be developing our user interface using the React. So you need to install the React, NPI React. I already installed all of these things. You can use this command to install this dependency, or maybe just this command. This command will help you to install all of the dependencies. After giving this command, if all of the dependencies are not installed properly, then maybe you can see that, okay, which one is missing. Sometimes maybe this last one might be missing. In that case, you can separately just issue this command and you can install this dependency. So first of all, we need to install the node.js, then we will install all of this dependency one by one, or I think if you just after downloading the folder, if you issue this command, then it will be okay. It will automatically install all the dependency. So however, we are covering it step by step. First, what you will do, from the Google Drive link, download the Lab 12 project. The project or application is given in a folder. Just go to this link and download it. Then keep the folder on the desktop and send your directory to desktop. So already I have this. Already I downloaded the document from this Google Drive link, and I put the folder on the desktop that I can show you. You can see it here. This one. So this is the BC forensic. I already downloaded and I put it here. So what I will do now? Now I am at the second step. I will change my directory. I'll go to desktop, and then I will enter into my working folder. The working folder name on my desktop here name is BC_forensic, but if you download from this link, then the name is lab12. So here, as I give the different name, that's why I just write the different name. Okay, now I am in my working folder. The next step what I need to do, this one, nv install. Already I have installed, that's why I am not giving this command because it will take some time. Already I did that, but you will give this command next. So first of all, you will download the lab12 from your Google Drive link and keep it on the desktop, then send your directory to desktop, and then go to your working directory and then give this nv install this command. Next, you need to install some tools. First of all, we need to install the ganache. Command to install the ganache. From here, you can do that. But before downloading this BC_forensic folder, you can install ganache, you can install Turtle Suite, you can install other necessary tools. Even uploading this, you can do that. But do that one by one. So now you need to blockchain, because our purpose is to send our report on the blockchain. And we are going to install the blockchain, local blockchain, Ethereum blockchain, ganache. This is the command to install the ganache blockchain from your command line. But you will have also graphical installer. If you click this www.turtlesuite, you will have a graphical installer. Just click and you can install, or you can use the command, this command. I already actually installed this ganache, that's why I'm not giving this command again. Just I am showing you, or maybe graphically I can install. So as I already installed, just I like to start this ganache. I need to start this ganache. This is the ganache. So I will start this. This is my blockchain. I like to show you how this blockchain look like. Click here, quick start. So this is my blockchain, local blockchain, and this blockchain has 10 account, and already I got 100 Ethereum. This is called Ethereum. As we are not using the public blockchain, here we are using some fake Ethereum account. If you would like to upload your smart contract, then you need to upload your smart contract against this account. Everyone who participates in a blockchain will have an address and will have a pair of public private key. So as we are using Ethereum, so Ethereum already comes with some 10 account, free account, and this free account will have 100 Ethereum. If you use one of this account, then you will have 100 Ethereum. You can spend this Ethereum. If you upload your smart contract here, then your Ethereum will be reduced from here. So this is a blockchain. Here 10 account, and the address of this blockchain is, this is the address of this blockchain. It is running here with 47545 on our local PC, and the block of this transaction, no block we can see. There is no block because we did not issue any, we did not create any transaction, and so there is no block is created here. We can't see any transaction. See, there is no transaction also. So this is the block. This is the ganache. I already run it. Next, to develop the smart contract. What is the smart contract? I already said to you. The smart contract will be uploaded in this blockchain. The smart contract will help us to store our our digital report on the blockchain. To interact with the blockchain, we need a smart contract. Is smart contract actually interact with the blockchain on behalf of us? We can call the smart contract as a function from our application. So here next is you need to install the Tarful suite. This is another. So I have also this Tarful installed in my computer. If I give the here command, you can see that. So you'll install this Tarful. You can do that. But already I have this Tarful suite to be installed on my computer. So I can check whether my PC has it or not. If I write Tarful, then it should yes, many things come. So that means my PC has this software. So next, I like to show you the application, the project, how the project look like. Let's see that our digital forensic project. I think it's on the desktop. This is so. So our project look like this. I will not describe the code of this project. The reason is it will take a lot of time, and even you will not understand everything. So that's why I will just show you how it is working. If anyone interested, then he or she will explore it further. So the most important file in this project is called ap.js. And the smart contract that we are talking about, that we need a smart contract, we need a smart contract. Multiple time we are saying. So where this smart contract? Let's see how the smart contract look like. Any folder? This is the contract. So this is a smart contract. This look like this code will be uploaded on the blockchain. And our application, this is our application actually. So this is our application. This application will call this smart contract, and this smart contract will be uploaded on the blockchain. This is the things. And this will be our application. When I will run it, then you will understand it. Okay. So first of all, why I actually showed you that things. The reason is now we need to migrate a smart contract. We already develop our smart contract, but we need to upload this smart contract on the blockchain. So there will have a command, this command, tarful migrate. Tarful migrate. These are, it's a bit hard topics. You can't guess everything now, but don't worry. You will not have to submit any lab report on these things. Just see what is happening. By chance anyone can understand and anyone is interested, then that will be our success. So I already migrated my blockchain. I already migrated my smart contract on the blockchain. Let's see whether our smart contract are uploaded on the blockchain. And from this detail, we can see that a certain amount of Ethereum was needed, and to deploy contract.js. That means two smart contract, two function was deployed, naming as meme on the blockchain. When smart contract will be deployed on the blockchain, smart contract will have an address. So here we can see the address. This is the hash, and this is the contract address. This is contract address. So when blockchain will be uploaded on the smart contract will be uploaded on the blockchain, then new transaction will be created and new block will be created also. Whatever you put on the blockchain, block will be created. Everything will be stored in the form of block. So let's see now how many blocks in the blockchain. Now see, there are many blocks because our smart contract, our program, this there are some difference from normal document and this program. This program is also document. We are also putting on the blockchain, but this program can run, can give us execute if we call them. If we put any data on the blockchain, normal data, then that is just data that will be stored on the blockchain, and you can retrieve that data later. But this smart contract is a program. This is also data, but this is also program. So this program will be also uploaded in the blockchain in the form of block. So you can see there are now many blocks. We put two smart contract on the blockchain, but it has created other necessary blocks to keep these two smart contract on the blockchain. And we can see also the how many transactions. There are many transactions for this. Okay, it's already deployed. The next step, our next task is run our application. Still, we did not run our application. Now we are going to run our application. But before running this application, I need to add MetaMask on my web browser. Here I already added. This is the MetaMask. This is a special tools that sit in between blockchain and our user application. So blockchain containing our smart contract, and between smart contract and our user application, there will be a buyer, there will be a media that is called this, or this is a browser. You can tell that this is also browser. This browser is on top of our existing browser, MetaMask. This MetaMask will help us to communicate to blockchain, to communicate with blockchain. Okay. So first of all, what we need to do, we need to connect this MetaMask with the blockchain. So this is our blockchain. This blockchain should be connected with this MetaMask. How we can do that? Let's see. I'm showing you. I'm just avoiding the details description. You need to also understand how this MetaMask can be added here. And so we need to open an account on this MetaMask. So I am avoiding many important aspects. I am showing you just basic things. If you see the video tutorial given in the resources, then you will learn everything in detail. So what I will do that, I need to connect this blockchain with our MetaMask. I will copy this mnemonic and then I will go to this MetaMask. I will write here import using. I'll click this one. So at this stage, I am just connecting this MetaMask with our blockchain. Already connected. I did that. It's done. Now our job is to run our application and to let our application to connect with the MetaMask in order to communicate with blockchain. This is the themes. On the other hand, with a smart contract. Actually, with a smart contract. So let's see the command to run our application. Here we npm run start. npm run start. Okay. Now our application should run. Let's select our application. Okay, so our application, this is the user interface of our application, and our application is trying to inject Web3 into MetaMask. Our application, this user application, this is user interface, this application will communicate with blockchain via this MetaMask. So we are now clicking next so that our user application can connect with blockchain through this MetaMask. So our this user application is already connected with the blockchain through MetaMask. So this is the themes. On the other hand, our user application is connected with the smart contract on the blockchain. Smart contract is on the blockchain. Before running this user application, we already uploaded a smart contract on the blockchain. Now we have a user interface. Now we can upload our digital evidence on the blockchain. Let's upload our digital evidence. Choose a file. I don't have any digital evidence here, but I just, for example, this Australian logo is the evidence. For example, any file extension you can give it here. So this is, and then I'm submitting it. Cannot read properties of null method. There is a mistake that should not happen. Let's another perhaps we can try another document. Yes, this time it's okay. So we are uploading a digital evidence in the blockchain. So actually we are calling the smart contract as we are smart contract to upload our this document on the blockchain. In other words, we will be actually storing the hash code of this file on the blockchain, and this document will be sent to another decentralized storage that I mentioned you, that IPFS. So whenever we would like to upload anything on the blockchain, we will have to spend money here. This things is measured in the term of gas. So we need to spend that. We need to confirm that, okay, if we would like to record this on the blockchain, then this amount will be spent. We need to spend this amount. It will cost this amount if we would like to upload this document on the blockchain. So we would like to confirm, okay, we'll spend because we have 100 fake ether. And how can you understand that, okay, it has been done? We need to verify the blockchain, okay, it has been done or not. Before that, another things I like to show you here. One things. This file was first converted into buffer, and then this file is sent to the IPFS. This is a decentralized storage, and this storage will send us the hash code of this file, MD Ashraf Uddin photo file, and that hash code is this. This is the hash code that was sent by that IPFS, that decentralized storage. So our application, this application or smart contract will keep this hash code into the blockchain. So this hash code will be only kept into the blockchain. This hash code will be kept. So let's see the blockchain. Let's see if number of transaction has been increased or number of block has been increased or not, because we have just created a new block. Now the time is, according my PC, it's 12:10. We can see that a transaction number 5 that's was created 12:09. I think this is few minutes ago, just it was created when we upload the document. Let's try another document. We'll see that whether it's uploading or not. This is the transaction block number 5, and also see that transaction new transaction has been created. So to verify it, this one, let's choose uh, another file. Sorry, confirm, confirm. See, this is a different. Yes, different. This is different hash, different document has been put, and let's see this blockchain. See, this is 6 7 because we give the command 2 times, so that's 6 7. Two block already created on the blockchain because two documents have been uploaded. So later we can also retrieve this document, but this user application does not have that feature. I think have that feature also. Maybe if you let me choose a pixel, you can add that feature, but not so easy to add this feature. This blockchain technology, it's not so easy to understand. Why this one did not work? Ah, you can see here. So you can also retrieve document. This document is not retrieved from blockchain because blockchain only stores the hash code. You will just retrieve hash code from the blockchain to verify the integrity. But this one was retrieved from that IPFS, decentralized registers. That also works like blockchain, similar approach. So I have just tried actually to show you how a decentralized application works and how digital evidence can be stored in blockchain. These things I described to you, but I skipped the detailed description of code and also the tools and technique. The reason is you will not understand this tool technique now. Even to understand the smart contract, you need to learn a new programming language. Although not so hard to learn the Solidity language. If you are already familiar with any programming language, you are used to working with any programming language, then it's not difficult for you. You can easily learn the Solidity language. I have some lectures on Solidity language and also details discussion on consensus protocol, different lecture. Also, I have lecture on hyperledger fabric. If anyone is interested in knowing about the hyperledger fabric, then you can just see this lecture. Hyperledger fabric is another kind of enterprise blockchain technology developed by IBM that we mentioned in the theory class. To understand well about Ethereum, you can see this lecture Ethereum. I did not cover the basic of Ethereum blockchain. Every blockchain has different features. Every blockchain has some extra features that other blockchain might not have. That's why all of the blockchain are not the same. Even you can develop your own blockchain. You can uh, make a lightweight blockchain. Ethereum blockchain normally generate transaction within every 20 to 30 seconds. Hyperledger Fabric maybe more per second. I can't say the exact number, but per second many transaction or block are being produced. So throughput is very high in Hyperledger Fabric. So many one prefers to use Hyperledger Fabric instead of Ethereum. And Bitcoin blockchain that I already told you that 10 minutes is required to produce a block. Every 10 minutes, one block is produced. So that's takes huge amount of time because Bitcoin blockchain use the proof of work, and proof of work is a time-consuming protocol. Proof of work uh, example, we already saw the example of proof of work here. But proof of work is the most decentralized and most stable till now. The consensus protocol, Ethereum, um, is going to use proof of stake protocol. Proof of stake protocol, I should cover the should have covered the proof of stake protocol in the lecture, but perhaps somehow it is missing. As far as I remember, that I put one slide on proof of stake, but now I am not seeing it. Somehow it's missing in the lecture. However, I would don't like to actually make this lecture longer. Already you are feeling boring. You are already um, overloaded with many hard topics. Many of you perhaps have heard many things for the first time. So here I should have a lecture like in this slide. In the next slide, I added another slides describing how proof of stake works, but I'm not seeing it here. Maybe somehow mistakenly I just deleted it. So thank you everyone for being with me for this long time. Now tell me what you have understood. At least if you know that what's the blockchain, then and what can be done on the blockchain, that will be my success in this class. Can anyone give me any feedback? We'll be recording attendance very soon. Do you have any question? Please ask any question. Do you? No one has any question? So we are going to record your attendance. Hopefully everyone is here. Maybe some of you are sleeping. That's okay. But now you should wake up. So no one is asking any question. I think no one has understood anything. Or maybe, yeah, it's difficult actually to uh, grasp everything.
Okay, so I can ask you something like, if I have a Bitcoin, like I have 5 Bitcoin, then where it is stored? I have heard some of the accident, like a person losing the hard drive and then his Bitcoin is gone. So
Ah,
how,
okay.
yeah, how can you solve those problems?
It's very nice question. Thank you for asking this. I think you have some idea about Bitcoin. We know that Bitcoin is very established cryptocurrency and the most popular one. The thing is, where data is stored in blockchain. Data is ledger. Where is ledger stored in blockchain? Every minor node that will participate in mining process in the blockchain will have to first store the ledger, complete ledger. Then we'll attend the mining process. So every node that attends in mining will store your data, will store your um, currency. But the thing is that you ask that someone just lost his hard disk, then his Bitcoin is lost. One Bitcoin, that's huge value. Uh, the thing is actually he or she lost his private key and public key. You should store your credential somewhere so that never be lost. You should write those on the hard copy. Your public private address should be written on a hard copy, or you should keep it in a computer, in more than one computer, but uh, you should be ensured that no one see your private no one get that private public key. Otherwise they can access of uh, your, if anyone get your private key, then he or she can access your Bitcoin also. So be sure about that. Otherwise if you lost your hard disk, you will not lose your coin. Only you will lose your coin if you can't remember your public private key. If your computer is crashed, you can upload, you can install Bitcoin apps on your computer, because your computer is the hub node. It's called hub node. There are there are two and three kind of node are maintained in blockchain. One kind is miner, who actively participate in mining process, run the proof of work. Another one is hub node. We are the hub node. If we would like to just um, sell Bitcoin, if you would like to do something that share market does, then we will be the hub node. We will just upload an apps to interact with the Bitcoin or original Bitcoin blockchain. So until you lose your public private key, you will not lose your uh, data, or you will not lose your Bitcoin, even your computer is crashed. So
So
someone,
I have one question.
yes, yes,
What if you have stored your cryptocurrencies in a hardware wallet like Ledger Nano or the other wallets?
yes,
But
yes,
if you have
wallet.
lost your wallet and still, if you have your private key, then your Bitcoins or whatever the cryptocurrency you have, you lost that. And if you store it on some online wallet like MetaMask or like Trust Wallet or anything else that is also developed by some developers, there is a team behind all these wallets, whether it is a hard wallet or it is a software. Uh, your I think so. I'm into this from 2000 since 2017. I have built my own mining machine and I'm into this since 2017. But I think so. It is not secure. Whether it is your hardware wallet, obviously there is some team behind your hardware wallet who is uh keep on updating the hardware wallets. They have the access to your private keys. And if you talk about the exchanges, a lot of exchanges ran away with billions of dollars and they never came back. So I think so it is not a uh, secure thing. Whether you have a private key or the public key, there is always a team behind it who have access to your assets, isn't it?
um, okay, I think as you have the practical experience with using wallet, then I'll say that from just I haven't used Bitcoin blockchain. We, for the research purpose, we normally develop our own blockchain, and also we read the research paper. And from our that basic understanding, that I know that if I have the private public key, then I can retrieve an address, then I can retrieve my Bitcoin. But as you
No,
have the
if you have
practical,
stored it in your hardware wallet, there are a lot of hardware wallets and a software wallet. The thing you have showed, MetaMask, you can store your assets on MetaMask as well. But the thing is, MetaMask is developed by some team, some
yes,
human beings. And if it is developed by some team, they have access to your assets. What if they just remove their code or they just stop their operations? Your assets will be with MetaMask, with not with you.
okay. So you are asking about that wallet issue, I think, but blockchain, uh, this issue is not with blockchain. The reason is blockchain will be stored by every computer, every miner, and no one has control on that blockchain code. But this wallet will be developed particular by a particular maybe developer, and then there is the concern of privacy, like they can see your public private key. You are asking about that issue, that things.
I'm just adding that my question is, do you think it will replace it will be used as a global mode of payment or global currency in the near future? Because I think so. I have read a lot of articles and I'm doing it practically, and I think so. It's not secure by any means. That's why it is not regulated yet. A lot of countries are not accepting it. The only country in the world is El Salvador who accepts it, and the people are against it. They are not happy with this decision.
Yeah, you're right. Your opinion is right, I think. Also, not fully security still, and blockchain is not also widely adopted yet. We are just using blockchain for different applications, for developing different use cases, but is still not fully adopted by any government. Maybe some government like Estonia, they adopted the blockchain for storing e-health data already. Um, but officially for maintaining the cryptocurrency or to replace the current system, still there are a lot of things to answer. I have a paper on the adoption of blockchain in IoT. There we mentioned a lot of challenges that might arise when we would like to adopt blockchain in IoT and in cryptocurrency. First of all, there is no regulation. And if we set regulation, then the basic theme of blockchain is violated. Blockchain will be open to all. But if we put here regulation, then someone is supervising it. Although Hyperledger Fabric,
Obviously, if you regulate, then the mean of developing the Bitcoin is dead. Like it's not a
yeah,
purpose of
that's right.
developing a Bitcoin, so it cannot be regulated.
So you have been using blockchain for a long time, I think.
Oh yes, sir. I started
Beautiful.
mining in 2017. I'm from Pakistan,
2017.
and
Oh,
I started mining in 2017. But
right.
then, unfortunately, there is a law that mining is illegal. Then I have to shut it.
Okay.
But I have started trading again in 2020. 2020.
So in Bitcoin, it's very competitor. I think very high competition. I mean, you need to invest a lot of resources. Is it possible for a person actually to invest that level of resource?
Well, you don't need to have a lot of money to invest in it, and you
You
can
can collaborate with other.
if you want to start mining it, you can mine just with start with 6 GPUs, but you'll get a very low hash rate, which can you need a very strong system, but you can start with 6 GPUs and one medium system for mining.
Okay. So do you have any idea about the application that we discussed today, like Ethereum, by using the Ethereum?
Yes, I frequently use this MetaMask because it is a decentralized exchange, not a centralized one. It's a decentralized exchange, and
Okay.
I used it regularly.
Oh, nice. Then I think in your final year, you can also develop a project or maybe research paper. You can work on a research paper using this technology, and that will be helpful for the next generation. I mean, next time the student will be studying this course or maybe other security related course, then they will also will do their research in this field. If you start, then other will follow you in MIT, I think.
Yes, I'll try.
So, what's the topics of your project currently? At your final year, you are going to, I think.
Yes, my topic is like we are developing a tool for website testing.
Okay. Maybe you can try to incorporate blockchain technology with your existing project idea.
Oh no, so it's entirely a different thing. That is just
Different.
a plugin for web application tools. So that is entirely a different thing. And we are today is the last class for this semester. So I think it's not possible now.
Okay. Yeah, that's not possible. And another thing is many research paper advises that we should not try to adopt this blockchain in all application. The reason is it's not applicable actually for all application. The application that really needs the decentralized environment, there we should try to adopt this application. Otherwise not. I mean, there are many efficient centralized solution. Do you think that is it right opinion?
Sorry, sir, can you repeat? I can't get you.
I mean, many research are tells that we should not try to adopt blockchain technology in all application. Only it should be adopted in those application that needs decentralized environment, that needs decentralization. I mean, if we say that, okay, we'll adopt the blockchain in storing health data. So we know there are many health data are being
So
generated.
there are more than 15 there are more than 5,000 projects in the market. Like there are more than 5,000 coins in the market right now, but they don't have all of them don't have their own blockchain. Most of the projects are on Ethereum blockchain, and now the most emerging blockchain is the Binance Smart Chain, which is the competitor of Ethereum blockchain. So most of the 90% of the projects are using different blockchains. Some are on Bitcoin blockchain, some are on Ethereum blockchain, and the most decentralized projects, 90% of the decentralized projects are on Binance Smart Chain because they have a very fast transaction processing speed and they have very low gas fees as well.
Yes, blockchain has the issue with throughput and also the storage. So that's why I am telling you that, like, if I would like to develop an application for a hotel, for example, restaurant, not hotel, not resident hotel, normal restaurant, then maybe only one hotel with that application, and that application should not be actually deployed on the blockchain or should not use the blockchain as the backend. The reason is a centralized solution is enough for that. But if we say that, okay, in order to control the gun, that who can have the gun, and when someone can have the gun, in US we know that there is not many regulation actually regarding the gun, but or government already has regulation but can't actually monitor properly. So in that case maybe blockchain can help. And also the in case of supply chain, blockchain is a good application. But for not all application, blockchain is good as it has some issues with throughput and also the storage. And that's why it's not suitable for all kind of application. That I was trying to say that.
Actually, the main thing with the blockchain right now is blockchain is a very good technology, but the people who are currently using it, they are not using it for the right purposes. They are just using it for making out the money, and they are just treating the Bitcoin as a stock. That's why they have a lot of security concerns. Like a single person like Elon Musk, he can just manipulate the whole market. So blockchain is a very good thing, but the thing the people are using it right now, it is not meant to be built for that purpose.
Yeah, you are right. Very true. Okay, I think we can record the attendance if no one has any question or no one has any opinion to discuss. If anyone has any opinion, you can discuss it with us. We will be benefited. Already we found one actually who has been using the blockchain since 2017. I started my blockchain research around June 2017 also. But we are actually reading research paper and also we are trying to find out the gap, research gap from research paper. And
I think he's gone.
sorry, I got disconnected. I came back again. So we are going to record our attendance. If anyone
Yes.
does not have anything to say. So we are here finally. Serial one is not here. 2, no. 3, 4, 5.
Yes, sir.
Okay, 5, 6, 7,
Yes, sir.
8,
Yes, sir.
9,
9, yes, sir.
10,
Yes, sir.
10, 11, 12.
10%.
Yes, sir.
12 is here. 13. 13 is not here.
Yes, sir. Yes, sir. 13 Arslan.
14. 14. 14. 15.
Yes, sir.
16.
Yes, sir.
17. 18. 19. 20.
19 friends, sir.
19 is here. Okay. 21. 22. 23.
Yes, sir.
24.
Present.
25.
Yes, sir.
26. 27. 28. 29.
Yes, sir.
30. 31.
Yes, sir.
32. 33. 34. 35.
Present, sir.
36. 37. 37 is here. One asked me a question. What can we expect in the final assessment task? Any template? 10 mark. I did not understand this question. Okay. 10. So 38,
Yes, sir.
Yes, sir.
39,
Yes, sir.
40,
Present, sir.
41, 42,
Yes, sir, present 41.
42, 43,
Present, sir.
44, 45,
Yes, sir.
46, 47, 48, 48, 49,
Yes, sir.
50. Anyone is missing? No. Now come to the PBL attendance. So we are finishing class here. First, let me record the PBL. In this class, we will be also recording the PBL attendance. So there will be no PBL class today.
Okay, sir.
Thank you, sir.
Welcome. What kind of question? I think Amar already discussed about final assessment in his theory class. So as a tutor, we don't have any say regarding final assessment, final question. Already Amar covered these things. So you can ask your other friend, or you can have the recording from him too. For final exam, I mean. And for lab and PBL submission, I think there is no template. Okay, so we are going to record the PBL attendance, attendance for PBL. So there will be no separate class. One, this is for PBL. 1, 2, 3, 4, 5. What happened? No one is responding. 2, 3, 4, 5, 6, 7, 8. No, I am not hearing anyone. What happened?
So number 9.
Oh,
We
okay.
don't know.
They are not here.
Maybe they left the class to
Okay.
join the to join the PBL.
I understand. Okay, I will have to go there also.
Yeah.
So I'm number 9. Sir.
Okay,
And,
let first record for those who are here. 9.
Yeah.
Okay,
Yes,
10,
sir.
Yes, sir.
11, 12,
Yes, sir.
13, 14, 15, 16,
Present, sir.
17,
Sir,
15
mark
present.
for 15.
15, 15 pheasant, 17, 18, 19,
Yes, sir.
20, 21, 22, 23,
Yes, sir.
24, 25, 26, 27, 28, 29, 30, 31,
Yes, sir.
32, 33, 34, 35,
Present, sir.
35, 36, 37, 38, 39,
38, sir. 38, sir.
30,
39.
38, 39, 40.
So do we need to attend? Do we need to log into the PBL class or not?
Yeah, I will also into PVL plus 40
Present, sir.
because some student just left the meeting. 41,
Present, sir. 41.
42, 43,
Present, sir.
44, 45,
Present, sir.
46, 47, 48, 48, 49,
Yes, sir.
50. Okay, thanks everyone. See you in future. Hopefully you will
So do we need to
do
join
well in
PBL too?
yes.
Do we need to join PBL?
Because we
No, those who already were here, you don't need to
Okay.
join the PBL class.
Okay. Thank you, sir.
somebody sent you a message in chat report number 8.
Okay, number 8. Number 8. Okay, done. Thanks everyone for being with me. And
Thank you
hopefully
so much, sir.
you'll do well in your exam. Okay.
Thank you so much.
Thank
Should we leave now?
Yes, you can leave now. Thanks.
Thank you, sir.
Thank you.